Hey everyone, welcome back. Today we're diving deep into some really fascinating AI research.
Hmm.
We're talking about uh, multimodal large language models, MLLMs.
That's right.
These are AI models that can understand not just text, but images too.
Yeah, it's like they have eyes, they can actually see and interpret what's happening in a picture. It's pretty amazing.
It is. And the specific model we're focusing on today is called Florence VL.
Ah,
And it takes a really unique approach to visual understanding, which
mm,
we'll get into. We've got a research paper and some supplementary material to guide us.
right.
So let's just jump right in. I'm already super curious to hear more about this Florence VL and how it works.
Well, it's actually built on another model, Florence 2, which is a generative vision model.
Okay, so this Florence 2, can it actually like create images?
Yeah, like those AI image generators you've probably seen online.
Right, like DALL-E or something, right?
Exactly. But the cool thing is, being able to generate images actually helps Florence 2 understand visual concepts on a much deeper level.
Hmm, that's interesting. So it's like by learning to create, it learns to understand.
Yeah, exactly. Kind of like if you want to really understand art, you should try painting yourself.
Yeah.
And you get a whole different perspective.
That makes sense. So Florence VL has this super powerful image generator, Florence 2, at its core.
Right. And it uses this cool technique called depth breadth fusion or DB fusion.
Okay, depth, breadth, fusion.
Yeah, so imagine you're looking at a painting, right? You can get up close and see all the details, the brushstrokes, the texture of the canvas. That's like depth.
Okay, I see. Getting into the nitty-gritty.
Right. But then you can also step back and see the whole picture, the composition, the emotions it evokes. That's breadth.
So Florence VL is doing both, like looking at the details and the bigger picture.
Exactly. And it combines both of these perspectives, depth and breadth, to get a really rich understanding of the image.
That's fascinating. I'm already starting to see how this is different from other vision models like CLIP.
Yeah, CLIP is good at getting the general idea of an image, but it often misses those important details.
Right, so CLIP might tell you there's a dog in the park,
Exactly.
but Florence VL can tell you what breed the dog is, what color the frisbee it's chasing is, and even what the weather's like.
You got it. And that's all thanks to DB Fusion.
Okay, so I get the depth part, looking at the image closely and from afar, but what about the breadth? You mentioned DB Fusion uses different prompts, right?
Right. So in addition to looking at the image in different ways, Florence VL also uses different prompts, like you said, to ask different kinds of questions about the image.
Ooh, that's interesting. So it's like having different experts weigh in on the same picture.
Exactly. And those different prompts allow Florence VL to extract different kinds of information.
So can you give me an example of what kind of prompts they use?
Sure. One prompt might be describe everything you see in this image, kind of like a general overview.
Okay.
Another might be read any text you see in this image, which is really useful for OCR tasks.
Ah, so it's actually trying to read any text in the picture.
Yep. And then there's the dense region caption prompt, which basically asks the model to describe different regions of the image in detail.
Wow, so it's really dissecting the image, looking at it from every angle. But I'm curious, with all this information coming from different depths and breadths, wouldn't that create a lot of chaos for the model to handle? How does it manage all that data?
That's a great question. And that's where the fusion part comes in. They use a clever technique called channel integration.
Channel integration. Okay, tell me more about that. What is that?
It's a way of combining all this information without making the model overly complex. Imagine you're learning about a city. You could read a book, look at a map, talk to locals. Each gives you a different piece of the puzzle.
Right, and you'd want to combine all those pieces to really understand the city.
Exactly. That's what channel integration does. It takes all those different pieces of information from different depths and breadths and combines them in a way that makes sense.
So instead of getting overwhelmed by all the data, it organizes it, like putting all the puzzle pieces together to create a clear picture.
Exactly. And this approach is not just elegant, it's also really effective. The research shows that channel integration actually leads to better performance and faster learning.
Now, that's impressive. We've got this amazing image generator, clever fusion strategy, but I'm guessing there's still more to it, right? We need to actually teach Florence the L how to use all of this, like training it, right?
Absolutely. And that's where the training process comes in. Yeah, so training Florence VL is actually a two-step process. First, there's pre-training, and then there's instruction tuning.
Okay, two steps. So what exactly happens during pre-training?
Well, think of it like teaching someone the basics of cooking.
Yeah.
You've got to start with the fundamentals before you can move on to making fancy dishes.
Right, like learning how to chop vegetables, use different knives, all that stuff.
Exactly. So during pre-training, Florence VL is fed massive amounts of data, mostly image caption pairs.
So it's basically learning to associate words with images, like seeing a picture of a cat and then learning the word cat.
Yeah, pretty much. And it does this with millions and millions of images, so it builds up a huge vocabulary of visual concepts.
Okay, so it's building that foundational knowledge. But what about instruction tuning? How's that different?
So now that our chef knows the basics, we need to teach them specific recipes, right?
Ah, so now we're getting into the specialized stuff.
Exactly. Instruction tuning is all about fine-tuning the model for specific tasks, like answering questions about an image, recognizing objects, or even writing captions.
So it's taking all that general knowledge from pre-training and applying it to real-world scenarios.
You got it. And the results are really impressive. Florence VL outperforms a lot of other MLLMs in a wide range of benchmarks.
That's what I like to hear. So what kind of tasks is it particularly good at?
Well, it's really good at tasks that require understanding both images and text together, like answering questions about an image or describing what's happening in a scene.
So it's not just identifying objects, it's actually understanding the context, the relationships between things.
Right. And it's also really good at tasks that require specialized skills, like OCR, optical character recognition.
Ah, so it can actually read text within images.
Exactly. Like if there's a sign in the picture or some handwriting, Florence VL can often read it.
Wow, that's amazing. I'm starting to see why this is such a big deal.
Yeah, and the researchers actually measured how well different vision models, like Florence 2, align with language models.
So how well the visual part of the model is communicating with the language part.
Exactly. And guess what? Florence 2 showed the best alignment, even compared to other popular models like CLIP.
That's really interesting. So it's like Florence 2 has a natural talent for bridging that gap between seeing and understanding.
Exactly. And that's a big reason why Florence VL performs so well. It can really connect the visual information with the language.
Speaking of connecting information, the paper mentioned that Florence VL is particularly good at OCR and understanding charts. Why is that?
Well, remember those different prompts we talked about earlier? One of them was specifically for OCR, for reading text and images.
Oh, right. So it's like having a built-in reading expert.
Yep. And the researchers actually did some experiments where they removed that OCR feature, and the performance on those text-heavy tasks dropped significantly.
That makes sense. So it's really leveraging that specialized skill to understand the text within the image.
Exactly. And it's not just recognizing the text, it's understanding what it means in the context of the image. Like if there's a sign that says danger, Florence VL can understand that that might mean there's something dangerous in the picture.
That's pretty amazing. It's not just reading, it's comprehending.
Right. And this brings us to another interesting area where Florence VL excels: knowledge-based tasks.
Oh, yeah, those. I remember reading about those. What exactly are they?
So these are tasks that require the model to use its knowledge about the world, not just what's in the image itself. Like, imagine you see a picture of the Eiffel Tower. You already know a lot about the Eiffel Tower, right?
Yeah, I know it's in Paris, it's tall, it's made of metal.
Exactly. And a knowledge-based task might be something like, what city is this landmark in? So the model has to use its knowledge to answer the question, not just what it sees in the image.
Ah, I see. It's like connecting the dots between the visual information and a whole network of knowledge about the world.
Exactly. And Florence VL actually performs really well on these knowledge-based tasks, especially when it's paired with a powerful language model.
So it's like having a super smart research assistant who can pull up all the relevant information about what you're looking at.
Precisely. And the researchers even did some experiments where they removed some of the extra information, like captions,
Yeah.
to see how it would affect performance on those knowledge-based benchmarks.
What happened? Did the performance drop?
You'd think so, right? But surprisingly, no. The
Yeah.
model still did pretty well, even without that extra information.
Wow, that's fascinating. So it's not just relying on those specific details. It's actually using its general knowledge to reason and make inferences.
Exactly. It's really impressive to see how the model can leverage its knowledge to go beyond the immediate visual input and really understand the bigger picture.
This is all so incredibly exciting. I'm already imagining all the amazing things this kind of technology could be used for in the future.
I know, right? But before we get too carried away with the possibilities, the researchers also highlighted some areas where Florence VL could be improved and some exciting directions for future research.
Oh, yeah, that's right. What were some of the things they mentioned?
Well, one idea is to make DB Fusion even smarter. Like, imagine if the model could automatically adjust how it combines information based on the task at hand.
Ah, so it's like giving the model the ability to adapt its approach, to be more flexible depending on what it's trying to do.
Exactly. Instead of using a fixed combination of features, it could learn to prioritize different aspects of the image depending on what's most relevant.
That would be incredible. It's like having a Swiss Army knife of visual understanding, always ready with the perfect tool for the job.
Another area they're exploring is developing even more adaptable vision models. Imagine a model that can dynamically adjust its focus, kind of like a camera
Oh,
lens.
I see. So if it needs to understand fine details, it can zoom in, but if it needs a broader view, it can zoom out.
Precisely. It's like having a model that can see the world with incredible clarity and flexibility.
It's mind-blowing to think about all the potential applications of this. But I'm also curious about the challenges.
You're right, it's not all sunshine and roses. As we develop these increasingly powerful AI systems, we need to be mindful of the potential risks and ethical considerations.
Absolutely. Like, how do we ensure these models are used responsibly and don't end up causing harm?
That's a crucial question. We need to make sure these models are fair, unbiased, and don't perpetuate existing social inequalities.
That's a huge responsibility. Feels like we're stepping into uncharted territory here.
We are. And it's important to have these conversations now while the technology is still developing.
Well, on that note, maybe it's time to shift our focus from the technical details to the bigger picture. What does all of this mean for the future of AI and its impact on our lives?
It is a big question, but it's one we need to be thinking about
Hmm.
because the possibilities are pretty mind-blowing.
I'm all ears. Give me some of those mind-blowing possibilities. What could a world with advanced MLLMs like Florence VL look like?
Well, for one, imagine a world where searching for information online is as easy as thinking about it. You could just show your AI assistant a picture, and it could instantly find you everything related to it.
So like if I see a cool pair of shoes someone's wearing on the street, I could just snap a pic and my AI could find me where to buy them.
Exactly. No more digging through endless pages of search results. Or imagine you're traveling in a foreign country and you see a sign you can't read. Your AI could instantly translate it for you just by looking at it.
Oh, wow. That would be so helpful. No more awkward language barrier moments.
Yeah.
And think about how this could revolutionize accessibility. AI could describe images in detail for people who are visually impaired, giving them access to a whole world of visual information they might not have been able to experience before.
That's a really beautiful thought. AI could really break down barriers and make information more accessible for everyone.
Exactly, and it doesn't stop there. Think about healthcare. An AI could analyze medical images like X-rays or scans and help doctors make more accurate diagnoses. It could even help researchers discover new treatments by sifting through massive data sets of medical information.
Wow, the potential in healthcare is huge. It could really change lives.
And in education, too. AI could create personalized learning experiences for each student, adapting to their learning style and pace.
That would be amazing. Every student could have their own personalized tutor, helping them learn and grow in the best way for them.
Right, and not just education. Think about all the creative possibilities. Imagine collaborating with an AI to write a song or paint a picture or even design a building.
That's wild. The possibilities really are endless.
They are, and these are just a few examples. As this technology continues to develop, we can expect to see even more amazing and unexpected applications.
I'm definitely getting a sense of that. It's all so exciting, but I also feel like with such powerful technology comes great responsibility, right?
Absolutely. That's why it's crucial to be having these conversations now. To think about the ethical implications of this technology, we need to make sure these models are developed and used responsibly, that they're fair, unbiased, and don't cause harm.
It's a big task. But it sounds like the researchers are aware of these challenges and are working to address them.
Yeah, they are. And it's important for all of us to be engaged in this conversation as well. The future of AI is not something that's happening to us. It's something we're all creating together.
It's a great point. We all have a role to play in shaping this future.
Exactly. By staying informed, asking questions, and demanding responsible development, we can help ensure that AI is used for good.
I love that. Using AI for good. That's a future I can get behind.
Me too. And thinking back to Florence Vial, It's not just the technology itself that's so impressive, it's also the thoroughness and thoughtfulness of the research behind it. They didn't just create a cool model, they really dug deep to understand how it works and what makes it so effective.
Yeah, those ablation studies were really interesting. It was like they were taking apart a clock to see how all the gears work together.
Exactly. And by understanding how it works, we can learn how to make it even better, more robust, more reliable.
And hopefully more beneficial for everyone.
Absolutely. So, as we wrap up our deep dive into Florence Viel and the world of multimodal large language models, I hope our listeners are leaving with a sense of wonder, excitement, and maybe even a little bit of healthy caution.
That's a great way to put it. It's an exciting time to be following the field of AI, and we can't wait to see what the future holds. Thanks for joining us on this journey, and we hope you'll continue to explore with us as we dive into more fascinating topics in the world of AI.